Okay, for numbers 4 and number 5, the instructions state use the quadratic equation to find the roots. Again, we're going to use the quadratic equation, the negative b plus or minus the square root of b squared minus 4ac all over 2a. And also, you can go to page 6 in your notes. They will go over this as well, page 6 and probably page 7 as well, but you're going to get some good examples there. Either way, so here we go. We're using our quadratic equation. So again, we got a, b, and c. Again, they're the coefficients. They are not the x's. If you see an x in your quadratic equation, you have done it wrong. So negative b is negative 5, so that turns it into a positive 5. Don't know what I'm writing there. Positive 5 plus or minus the square root of b squared, so that's negative 5 squared, which if you can write it like that, or if you want to just go ahead and square it and write it 25, that's fine too. Minus 4 times your a value, which is 4, times your c value, which is 2, all over 2a, so 2, and then a, which is 4. And again, if you want to write, go ahead and write things like 8 down there instead of 2 times 4, that's fine as well. Just making sure everyone's tracking with me. So from here, we are going to just reduce the part underneath the radical to make sure that it works. We're reducing the part just under the radical, not the radical itself, because we want to simplify this just as much as we can. So we got 5. Again, Mr. Hunter needs to worry about how to work the program. That's 5 plus or minus the square root of, in this case, the part underneath the radical, when you plug in your calculator, comes out to a negative 7. Go ahead and erase this part right there. Turns into a negative 7. All over 2 times 4, which is 8. Now we have a negative underneath the radical. Our discriminant is negative. And if you remember from numbers 1, 2, and 3, a negative means we're going to get 2 imaginary roots. So this is when we start, and there comes my son out of the middle of nowhere having a little bit of fun, but there you go. That was the drive-by. And since negative 7, we cannot reduce the 7 at all. There's no perfect square that goes into 7. We can't reduce the radical, but this negative inside of there, we can most definitely pull that out. Whenever we have a negative underneath the radical, we have an imaginary number. So we pull it out and we make it an I to represent imaginary. So your answer is 5 plus or minus I times the square root of 7 divided by 8. For number 5, we're going to use the same quadratic equation that we did for number 4, but this time things aren't in the right order. We got to move everything to one side, and I'm going to move it left because I like to keep my x squareds positive. That's simply personal preference. You don't need to do anything. So when I move the x squared to the left, it becomes a positive x squared. I have a 4x over there. And when I move the 3 to the left, I got to subtract the 3, so it becomes a negative 8 equals 0. All right? And from there, I get my a, b, and c values. Okay? And again, that's a 1, because there's nothing there. Give me a second. So again, negative b plus or minus the square root of b squared. Our b value is positive 4, so negative b, so negative 4 plus or minus the square root of b squared. So I'm going to go ahead and write 16 here because b squared is 16 minus 4ac, 4 times 1 times negative 8 is the c value, all over 2a. And if you're one of my students and you don't have that song stuck in your head for good by now, shame on you. You're not paying attention, or you're skipping class, one or the other. So here we go again. Negative 4 plus or minus, and then we're going to do 16 minus 4 times 1 times negative 8. So real quick, 4 times 8. Oh, man. Sorry. 4 times 8 is 32, so 16 plus 32 is 48. So square root of 48 over 2. Let me erase this. All right. From here, we reduce the square root of 48. If I go over here and just chicken scratch a little bit, 48, you recall, is 16 times 3. Square root of 16 is 4. So the square root of 48 reduces down to 4 on the square root of 3. So I am going to rewrite this as negative 4 plus or minus 4 on the square root of 3 all over 2. And the last thing I can do is, since all three of these are divisible by something, I can divide all three of them by 2. We're just going to go ahead and do that. So negative 4 divided by 2 is negative 2. 4 divided by 2 is 2. And the square root of 3. And since 2 divided by 2 is 1, we never write divided by 1. We're just going to go ahead and leave it just like that. That is your reduced form. What up, Elliot?